Welcome to multiple choice question 27 of the 2005 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of the CAS calculator is really not that appropriate for this question. Although if you did define a suitable function on your CAS calculator, you might be able to use trial and error to get a greater understanding of what's going on in this question. For question 27, we have the graph of a function f with a domain of negative a to a, where a is a positive real constant, and the rule y equals f of x is shown below. The function g, which also has a domain of negative a to a, is defined to be the integral from 0 to t of f of x dx. And we are asked, then, if this is the case, g of t is greater than 0 for one of the following options. So looking at the function g of t, this integral is really just going to calculate what we could understand as being area under a curve, either positive or potentially negative, and we'll have to investigate that. Now looking through the options of a through e, we notice that the point 0 comes up a few times, so it's worth investigating what happens when t is 0. So if t equals 0, then g of 0, which is the function that we're investigating, is going to be equal to the integral between 0 and 0 of f of x dx. However, if we integrate between the same terminal, so from 0 to 0, the area under that curve would equal 0. And returning to our question, we can see that g of t is greater than 0 is what we're asked to investigate. So anywhere that includes 0, for example, C is for t is an element of 0 included to a, we have to exclude, because if t is 0, then the function g of t won't be greater than 0, it will be equal to 0. So we can cross out C, and we can also cross out D. And now we've got three options remaining that we need to investigate. So the next case that I'll look at is if t is 0 not included to positive a. So that would mean that g of t is the integral between 0 and some positive value of t up until a for f of x dx. And again, this is used to calculate the area under a curve, or that's how we can interpret that calculation. So if we think about some positive value of t, if I just put it here, then that area is above the x-axis, so it's a positive value, which means that that integral would be a positive value. So coming back to our options, if we look at option E, this says that nowhere in this interval is the g of t function greater than 0, which we know is now incorrect. There is some region where we can get the integral to be positive, so we can rule that option out. And the last thing we really need to know is what happens when we calculate that integral for t being between negative a and 0. So to answer this question, what happens if t is somewhere down here? I'm going to start with a little diagram. So this is the area that we're going to consider. And if we were just going to calculate that integral directly to get an area for that, we would have the integral of t to 0 of f of x dx, and that would calculate the integral for this region here. And we know that that would be less than 0 because the area is below the x-axis. However, our function g of t isn't the integral from t to 0, it is the integral from 0 to t, so we've swapped the terminals, of f of x dx. And that, if we swap the terminals, will result in a positive value rather than a negative one. So this here, we are considering the case if t was an element of negative a to 0. So using what we've just found, and there was a lot going on there, but we found that if t was between 0 and a, 0 not included and a included, we got a positive value out for g of t. And if we had t being from negative a included to 0 not included, we also got a positive value out because we went from 0 to t rather than t to 0. So we got positive values for both of those calculations, which means that A is the correct option for this question. So that question took quite a bit to work through and reason through, and we can see on the examiner's report that only 21% of students got this question correct in the exam. And when the distribution of percentages look a little bit like this, you might suspect that some students have just guessed at the correct option, maybe ruling out D and E and then just having a bit of a estimated or educated guess at options A, B and C. So the examiner's report goes on to say, to answer question 27 correctly, students needed to know the properties of integrals and to be able to calculate the area of a region under a curve, or at least know how to do this, what the process of doing that would be. The examiner's report then just goes on to describe what we discussed on the previous slide. So as you can see, as t is a positive value, so between 0 not included and a, the integral from 0 to t of f of x dx is a positive value. So that's what the calculator is computing right there as those numbers change. And as we go back towards 0, and in a moment we'll see what happens when t is in the negative direction. So here we're about to see t is in the negative direction now, and we can see that the integral now from 0 to t of f of x dx is now positive. And that's because instead of integrating between t and 0, the terminals were swapped, so it's now between 0 and t. So swapping the terminals on what would be a signed negative area makes it positive. And we can see that as t approaches 0, we can see that the integral is equal to 0 when t is 0. So that's why we had to exclude that from our answer, which made A the correct option on the previous slide.